Hey all you cool cats and kittens, today we're going to be learning about the sine rule, which is the first of the rules we're going to deal with for non-right angled triangles. Now this little sheet here has got a nice little flow chart, I suppose you could call it, for what rules to use when we're trying to figure out things about triangles. So if it's a right angled triangle, we're over here on the left, and we can use Pythagoras, so we can use SOHCAHTOA. But if we don't have a right angle, then we've got the sine rule and we've got the cosine rule. And today we're going to be dealing with the sine rule. And so for the sine rule, we need two angle opposite pairs. I'll talk about that what it means in a moment. Involved and one angle or side not known. So we'll talk first about what is the sine rule look like and how we use it to find an unknown side. So here is the sine rule written as it is in your formula sheet. And it just says that if we think about any triangle, this one down here will do, we use uppercase letters to refer to an angle, and we use lowercase letters to refer to the side that is opposite the angle. So much like the hypotenuse is opposite the right angle, so we're not talking about next to, we're talking on the other side of the triangle. So here we can see that angle B is opposite side B. Okay, so what we're saying is if we create a fraction where we put side B over sine of the angle B, that'll be equal to side A over the sine of angle A, and so on. So effectively it creates an equivalent ratio. Now we don't ever use all three of those. You don't need two equal signs. You just cherry pick the bits that you need, the two that you need in order to solve your question. So in this particular instance, what we want to do is we want to write it so that the thing that we're trying to find is the thing we're trying to find is in the top left. So it says that here. I'll just use a bit of highlighter. It just makes it easier for us to rearrange it. So in this particular instance, we have an angle and a side that we know. And in blue, we've got another angle, but we don't know the side. But that's okay, because that's four things. So we'd sort of write this out. In this particular case, we're dealing with A and B. So if we wrote that out, we'd have A over sine A equals B over sine B. Now, we don't worry about the C over sine C in this case. You only ever need to use one pair of fractions. So in this particular case, we just start filling in, like as always, we fill in what we know. So I suppose the only thing we'll probably do in this case is we might just rearrange that and call that B over sine B equals A over sine A, and that'll just mean that we don't have to rearrange it. It's going to come out with B equals this. Okay, so if we start filling in the details, B, we don't know, that's the side that's not given, but we know that the angle B is 41 degrees. And we know that the length of side A, the side that is opposite angle A, is 85. And that's got to be over sine of the angle A, which is 109 degrees. So as we move along with that, we could just multiply both sides by sine 41, because that'll cancel out on that side. So that's going to cancel out with that, and we're going to end up with B equals 85 sine 41 degrees on sine 109 degrees. If you don't like the way that's written, you could also write that as 85 on sine 109 times by sine 41 degrees. Just make sure you get your order of operations correct on your calculator. Either way, there will work out exactly the same on your calculator. So we now just put that into our calculator, and I'll just move across to here. So we're going to have 85. We'll create a fraction actually first. Sine, and we're 41 degrees. We'll close our brackets. Then underneath, we're going to have sine 109. And then we just press equals. Oh, it's probably better to put a multiplication sign up there between 85 and sine. It's not 100% necessary in the calculator, but if you're using a different model of calculator, it might not work. The Casio does that quite well. So we press equals and we end up with, what's that, 58.97. So we might call that just 59 to the nearest centimetre. Okay, and that's basically all we do with the sine rule. So just get it written in such a way that the thing that you want to know is in the top left. So we wanted to know side B, so we did that first. So B over sine B equals A over sine A, and like always, we just substitute in the bits that we know. There's 4 things you need to know for this formula, or that this formula has in it. So you're going to know any 3 of those 4 things at any given time to work it out. So here's another example. We've got what we want to know here is this side X, which is opposite angle A, so that's going to be side A. And we know that this side here, which is going to be opposite angle C, so that's side C, we have a distance on it. So we're looking for 2 sets of pairs of angles and sides that correspond to each other. So in this particular case, we want to put our unknown at the top left. So we'll have A over sine A equals C over sine C. Like I said, we only need 1 pair, so we don't really care about B in this case. There's nothing interesting about that one in this particular question. So as we substitute in what we know, A is what we don't know. Well, we know it's called X in this occasion, so we'll call it X. And that's going to be over sine 75 is going to be equal to C, which is 12.5 metres, over sine 55. So obviously at this point I'm going to have to multiply both sides by sine 75. That's going to cancel them out on that side. And so we're going to be left with X equals 12.5 times by sine 75 over sine 55. And we'll put that into our calculator and see what comes out. So so I'll create the fraction first. 12.5 by sine 75 is going to be over sine 55. And we press equals and we end up with, what's that, 14, we'll call that, I'll just check on the rounding, 14 points, it doesn't say, so we'll go with 14.74. And that's metres, and that's to 2 decimal places. For the next example, we have all the information we need, but not in the form we need it. So obviously, it's quite easy to see that this particular angle here is opposite the side we need to work out, so that's important. But the angle that's given there, the other 55 degrees, is opposite a side we know nothing about. So what we'd be better off doing is knowing, well, really what we want to know is this angle here, because that's going to correspond with that number there. Now, obviously, if we already know what 2 angles in a triangle are, we should be able to work out the third. So obviously, if there's 180 degrees, so that angle C, if there's 180 degrees in a triangle and we take away 40 degrees, which is one of the other angles, and we take away 55 degrees, which is the other one of the angles, that's going to give us, I think, 85 degrees. 40 and 50 is 90, 95, so yes, we're going to end up with 85 degrees. So now that we know that, now we can start to use the sine rule. So we just write that sine rule out. Now in this case, we want to have the side A angle, or the side opposite sine A, or sorry, the angle A is the one that we want to put first, and that's going to equal C on sine C. So we just substitute in what we know. So in this case, A is just X, sine A is going to become sine of 40 degrees. The side C is 29.6 centimetres, sorry, and then that's over sine C, C being 85 degrees. Now, much like the previous examples, we multiply both sides by sine 40 degrees to cancel that out, but of course, if we do that to one side, we've got to do that to the other side. So we're going to end up with here with X equals 29.6 over sine 85 times by sine 40 degrees. I'm doing things the other way just to show that both ways work out. Whether you can either put that sine 40 in the numerator or you can put it out to the side. Either way will work. So if we go 29 point, so I'll just move that out of the road of my face. There we are, 29.6 over sine 85. Close our brackets off, and then we can multiply that by sine 40. We close our brackets off there, and that's going to give us 19.09. We'll call that 19.1 centimeters was the units. Centimeters to 1 decimal point place, sorry. Okay, the next variation we need to think about is, well, what happens, that was all good if we were finding a side, but what if we need to find an angle? And the simple thing is we can flip, the easiest way to do that, you can keep the sine rule this way if you want to, but it makes a whole lot of work. We can flip that over. So if A over sine A equals B over sine B, then the other way around, sine A over A is going to equal sine B over B. So we can just, if we're trying to find an angle, we just flip the whole thing upside down. As long as all the sines are on top and all the distances are down the bottom, that'll work out. Okay, so just to see that going in action, here we have one side and a matching angle, and we have another side, but we don't know the matching angle. But we know 3 of the 4 things we need to use the sine rule, so let's use the sine rule. So remember, we want to have the thing that we don't know first in the top left, and that in this case is going to be the angle C. So we're actually going to have sine C on C equals sine A on A. And then we just substitute in what we know. Sine C we don't know, but we do know that C is 63, and sine A is going to be sine 43, and the length of A is 85. So now, much like before, we just need to get sine C on its own. So if we multiply this by 63, we'll have to multiply the other side by 63 as well. And that's going to leave us with sine C equals 63 sine, or times by sine 43 over 85. Now you could put that all in sine to the minus 1. I think I'd be inclined to break this up. So I think I'd be inclined to calculate that out first. Use the calculator. So we're going to go we'll start a fraction first. 63 times by sine 43. Close our brackets. Over 85 is going to give us a number. And I might just write that down. So 0.50548. And I'll just leave some dots to say that keeps going. That's going to be what sine C is, so therefore C is going to equal sine to the minus 1 of 0.50548 ... So this is where we use that answer key on the calculator, and we just go sine to the minus 1, because we're finding an angle, just like in right angle triangles, sine to the using the shift button finds us an angle. And then we just put answer there in the brackets, and that's going to give us our angle, which is 30.36 degrees. Were we asked to find it to the nearest minute? Yes, we were. So we'll put that in degrees, minutes, and seconds. So that's 30 degrees, 22 minutes, because 47 rounds up. Sorry, 30 degrees, 22 minutes. Okay, and I'll have to pause there because we've run out. I'm going to run out of time. I won't get enough time to do this full example, but I will ask you guys to do that in Edpuzzle, I would say. But obviously in this case, I've got a matching angle and a matching side, and I've got a side and the match angle's blank, so I'm going to need to write that in the right way. So just to get you started, I'm going to write that one using the formula in the form of sine A on A equals sine C on C. So have a crack at it from there, and I'll get you to give me the answer in Edpuzzle. Have a good day.